Good morning, my dear student. On the behalf of KTGM College, Nasik and Department of Chemistry of this college, I am Dr. S.R. Labhade welcomes you to the lecture on hydrodynamic voltammetry. Student, in previous lecture we discussed the drawbacks of polarographic analysis. One of the most important drawbacks of polarography that is related with the growth of mercury drop in TME. Growth of mercury drop in dropping mercury electrode gives a oscillating current voltage curve. So it is difficult to determine the limiting current in polarographic analysis. Second disadvantage is that in polarographic analysis, diffusion process transports ion to the electrode surface, and due to this, diffusion process is very slow compared to hydrodynamic voltammetry or compared to stirring of solution. Therefore, here by stirring of solution, analyte transported in a faster rate, a steady state in limiting current that will be achieved very easily and fastly in case of hydrodynamic voltammetry. Therefore, diffusion process is slow and it takes more time to reach a steady state in diffusion current, steady state in limiting current. Therefore, due to these different disadvantages, there is need of a hydrodynamic voltammetry. In a hydrodynamic voltammetry, analyte solution is continuously kept under motion so that transportation of ion to the electrode surface is fast, and here the limiting current achieves a steady value very fast, and therefore there is need of hydrodynamic voltammetry. Therefore, in hydrodynamic voltammetry, mass transfer phenomenon is because of convection. That is, a analyte solution is stirred and mass transfer phenomenon is faster, so that a limiting current reach to steady state in a short time. Second advantage of this hydrodynamic voltammetry, we using a stationary electrode of fixed surface area. The oscillations in polyagram that can be eliminated, because the surface area is fixed. Therefore, rate of reaction is controlled by the surface area of the electrode, and therefore that eliminates the oscillations in a current voltage curve or polarograph. Because of the convection phenomena, steady state in limiting current reach very fast, and here the sensitivity as well as precision are more in hydrodynamic voltammetry. That means if we compare the polarography and hydrodynamic voltammetry, first of all, polarography, that is a linear scan voltammetry performed in a quiescent analyte solution, and analyte species are transported to the electrode surface by a diffusion process. Diffusion process is slower than the convection process. Therefore, here sensitivity as well as precision in case of voltammetry is very low compared to, in case of polarography is very low compared to hydrodynamic voltammetry. In addition to this, size of mercury drop in case of dropping mercury electrode is continuously changing, and therefore it gives the oscillating voltammogram or oscillating polarogram or current voltage curve. And from this current voltage curve, it is difficult to determine the limiting current. And third disadvantage is that here diffusion process is very slow, therefore steady state in limiting current that takes a time in a polarographic analysis. But in case of hydrodynamic voltammetry, convection is a process by which analyte species are transported to the electrode surface, which is fast compared to diffusion process. Therefore, steady state in limiting current that will be achieved very faster rate. And second thing is that sensitivity as well as the precision is more in hydrodynamic voltammetry. In addition to this, in hydrodynamic voltammetry, we are using a stationary electrode of fixed surface area that automatically eliminates the oscillations in the current voltage curve. And therefore, here hydrodynamic voltammetry is superior than the polarography. Therefore, here with these advantages, we know that the hydrodynamic voltammetry can be performed. Hydrodynamic voltammetry can be performed by number one, stirring the analyte solution, which is in contact to stationary working electrode. Second thing is that if we stir the analyte solution, convection phenomenon is possible. Similarly, stirring can be achieved by rotating the working electrode with a constant speed, so that stirring can be achieved. And third phenomenon by which we can perform the hydrodynamic voltammetry is that in this case we can mounting a working electrode in the path of analyte solution. Therefore, hydrodynamic voltammetry is related with the flow of analyte solution, and here analyte solution is kept in motion. That can be kept in motion by stirring the solution with a magnetic stirrer, or sometimes by stirring the solution with the rotating the electrode in analyte solution, and sometimes we can mount that working electrode in the path of the analyte solution in order to carry out the hydrodynamic voltammetry. Students, we discuss the working electrode in hydrodynamic voltammetry. Working electrode in hydrodynamic voltammetry, that is also a polarized microelectrode. Here, the hydrodynamic voltammetry can be performed with a great precision precision and accuracy by rotating the working electrode in analyte solution. Therefore, electrode itself is rotating in analyte solution. Therefore, here mass transfer phenomenon is faster than the stirring the analyte solution by using a magnetic stirrer. Therefore, definitely this is the most convenient way to carry out the hydrodynamic voltammetry. That is by rotating the working electrode with a constant speed in an analyte solution, and this is the convenient way to carry out the hydrodynamic voltammetry. Therefore, here in hydrodynamic voltammetry, working electrode is a rotating electrode. Here, the rotating electrode are two types. Rotating electrodes are of two types. Number one is rotating disc electrode, and second one is rotating wire form electrode. Therefore, here disc electrode or the wire form electrode are used in the voltammetric work. Here, generally disc electrode is preferred over the wire form electrode because wire form electrode have some disadvantages. First of all, we discuss what are the disadvantages of this wire form electrode. If we use wire form electrode, it will rotate either to its axis or to the axis perpendicular to its rotation, or to any angle to which the wire is placed or sealed. Therefore, here wire form electrode that will be rotated either its own axis or sometime the axis perpendicular to its rotation, or sometime to any angle to which that wire is sealed. Therefore, here where this wire is sealed outside the tube of that electrode, here wire during the rotation the wire is vibrating while electrode is rotating, and therefore when vibrations are taking place, then also a oscillating polyamogram is obtained. Therefore, here the oscillation in current voltage curve is also related with the vibration of the wire which is sealed in a rotating electrode. Therefore, generally a disc electrode is preferred in a voltammetric work. Normally, voltammetric work is also carried out by using a wire form electrode, but wire form electrode has this disadvantage. That is, when electrode is rotating on its own axis or perpendicular to axis of rotation, then here wire is vibrating. When wire is vibrating, there is oscillations in a current voltage curve or polyamogram. Again, a same difficulty that will be encountered in polarographic analysis. Therefore, to avoid this, generally rotating form electrode is used in polarographic analysis, in hydrodynamic voltammetry. Student, now we discuss the construction of this rotating disc electrode. The rotating disc electrode is constructed by using a platinum disc. The electrode is like this. Here there is heavy glass tube. To one end of heavy glass tube, a disc is sealed. Inside this there is mercury. Here this is He. This is a disc, and here a copper wire is inserted. Copper wire for electrical contact. If we view this rotating disc electrode from the bottom, then we have its structure like this. Here this is a glass tube. Inside the glass tube here, a one ring, platinum ring is sealed. In this fashion, it is a circular disc. And here another ring is placed in this fashion. This is the bottom view of the rotating disc electrode. This is a glass body. This is a platinum disc. Here this is an insulating material, and this is again a platinum disc. Here, in this way, the rotating disc electrode is constructed. Therefore, here, rotating disc electrode consisting of a heavy glass tube to the one end of the glass tube. Platinum ring is a seal as shown in figure. Outer surface of ring is exposed to analyte solution, while inside the tube a mercury is added. The purpose of addition of this mercury inside this tube is that this electrode is rotating. That means here, if wire is rotating, if they are sealed with this platinum disc, then here that electrode is not stable. Therefore, when this electrode is rotating, at that time here this wire is not rotating. It is at fixed position, and in order to maintain electrical contact between this disc and this copper wire, a mercury metal is used. Mercury is a metal, and therefore it is added for electrical contact in between platinum disc and the copper wire. Because here during the rotation, here sealed wire is not stable, and here mercury is added for electrical contact with copper wire. With electric motor, this electrode is rotated. With the electric motor, this electrode is rotated with a constant speed. constant speed, and then it will be act as a rotating disc electrode. In this way, the rotating disc electrode is constructed. It gives the constant surface area, and here there is no vibration of ring. Therefore, most of the time the disc electrode is preferred in hydrodynamic voltammetry. Similarly, we can discuss here the rotating wire electrode, and that is a rotating platinum wire electrode. Rotating platinum wire electrode is also constructed in similar fashion. Here it also consisting of a glass tube. To the end of the glass tube, a platinum metal is sealed. Sometimes here this platinum metal may be sealed in this fashion, right angle to the axis of rotation. Here inside the tube, a mercury is added, Hg. This is a platinum wire. This is a platinum wire at the angle of 90 degree of rotation. Here again a copper wire is inserted for electrical contact, and this is the direction of rotation. Here this is a platinum wire sealed at the angle of rotation, and this is a platinum wire sealed at the angle of 90 degree to the axis of rotation. Therefore, here rotating platinum electrode as well as rotating this electrode, both are useful in a hydrodynamic voltammetry. Therefore, here we can write construction of this rotating platinum electrode is the rotating platinum electrode consists of a heavy glass tube to the one end of glass tube, a platinum wire is sealed as shown in figure. With electric motor, the electrode is rotated at a constant speed, so that stirring takes place, and platinum electrode is exposed to analyte solution. Therefore, here this outer part of this platinum wire is directly exposed to the analyte solution. Student, here this is the construction of wire form electrode as well as disc form electrode. Both electrodes are useful in hydrodynamic voltammetry. First of all, please consider hydrodynamic voltammetry is a derivative technique of polarography. In polarography, dropping mercury electrode is used as a working electrode. It is not a stable or stationary electrode. Therefore, here study of solution is not possible by using dropping mercury electrode. In order to carry out this study, in order to transfer the analyte species by a convection phenomenon, here there is requirement of stationary electrode. Therefore, here if we use the stationary electrode, study may be carried out by using a magnetic stirrer. But the better way to stir the solution, that is by rotating the electrode. That is, if we rotate the electrode directly contact with the analyte species, and therefore here mass transfer phenomenon is more. Oxidation reduction reaction takes place with a faster rate, and here limiting current attain a steady value. Both in hydrodynamic voltammetry as well as in polarography, limiting current is measured. In both technique, limiting current is utilized for measurement of the diffusion current by subtracting the value of residual current. Residual current, that is the identity of the supporting electrolyte. Therefore, supporting electrolyte is also added in a hydrodynamic voltammetry. In both technique, limiting current is measured. In both technique, diffusion current is measured for quantitative determination of the analyte. Student, with this we stop here. In next lecture, we discuss the working of hydrodynamic voltammetry. Thanks for joining me. Wish you all the best. Keep learning. Happy learning.